Hey everyone, and welcome to a new era of .NET development with MongoDB at the third edition of the Software Architecture Conference by C Sharp TV. My name is Rishad Bhatia, and I'm a senior product manager at MongoDB, focusing on the developer experience for .NET and C Sharp. I'm based in Toronto, Canada, which is home for me since the last 2 years. Before which I spent the last 7 years in the US, but I'm originally from Mumbai, India, which is where I was born and raised. I actually started my career as an engineer working on C Sharp. So I was working in sports technologies, games, etc., helping build AR, VR apps, mobile apps before moving to product management in 2019. So yeah, that's a quick summary about me. Okay, enough about me. Let's talk about what is MongoDB and what is MongoDB Atlas for those of you who may not be aware with it. So firstly, MongoDB is a document database. So it's similar to a key value store. However, it supports a wide variety of data types, including strings, arrays, objects, making it more versatile. Unlike traditional relational databases, which store data in tables, rows, and columns, MongoDB uses BSON, which is binary JSON. The document-oriented approach allows for a more natural and expressive way to store data and can easily accommodate hierarchical relationships and array-based data as well. MongoDB is designed to meet the needs of different audiences. So if you're looking for a personal project, you can use it. Or if you're looking to build enterprise-grade applications in different industries like healthcare, retail, finance, etc., you can do so using MongoDB. One of the key features MongoDB has is its flexible schema. So unlike relational databases that require you to define a schema before storing or inserting the data, MongoDB allows you to store documents without prior definition or a structure. Lastly, MongoDB supports horizontal scaling. So it does so through what is known as sharding. So it allows you to distribute your data throughout a cluster of machines. This approach can improve performance and allows the database to grow exponentially as the user's needs are growing and makes it suitable for applications which require large data sets or high throughput requirements. Okay, so we know what MongoDB is. What is MongoDB Atlas? MongoDB Atlas is a fully managed cloud database that handles the complexity of deploying, managing, and healing your cloud deployments on any cloud service provider of your choice. It also offers SDKs or drivers, which facilitate the development of applications across a range of devices. So these help you developers integrate MongoDB Atlas into your application, allowing for seamless data synchronization and manipulation. And it works across different devices or different platforms, such as mobile and IoT. We also have charts. So charts is a feature which allows you to create visual representations of your data stored in MongoDB. So you don't have to go to any third-party tool. It's fully integrated into the platform, and you can generate charts, graphs for data analysis and reporting without any need for third-party tools. We also have analytics. So analytics allows you to perform complex queries and aggregate operations for your data, and it's optimized for performance and scale. So it makes it easier for your organization to gain insights on large volumes of data in real time. And lastly, we also have search. So Atlas Search is a fully built-in text search capability engine, which is built on Apache Lucene. It helps you perform rich text search queries without the need for a separate plugin or an engine. So this integrated solution helps you build search into your application by using MongoDB Atlas. Okay, so we've heard what MongoDB is, what MongoDB Atlas is. Now I want to touch on what is Entity Framework Core or EFCore. So EFCore is the most popular object relational mapper or ORM in the .NET ecosystem. Since it was introduced in 2019, it has really become the ORM of choice for C# developers and has widely gained popularity across these years. EFCore is compatible with different databases, and it can do so through plugin libraries called database providers. So you can switch between different database providers by switching the plugin or the provider in your application. This should not be considered a drop-in replacement, though, because each provider might work slightly differently. EFCore also uses the language integrated query or LINQ syntax, which allows you to use C# to write strongly typed queries. And the main reason why EFCore is so popular is because of its ease of use and the wide range of capabilities, which include entity splitting, lazy loading, custom conventions, etc., among many others. Okay, so why is all of this important? I want to quickly touch on some of the numbers here, which are taken from recent surveys, public surveys. One thing that we noticed is 39% of C Sharp developers said that they have used EFCore in some capacity. So they're familiar with it. It's one of the most popular technologies in the .NET ecosystem. MongoDB was also the number one NoSQL database for C Sharp developers. And a lot of developers who have not used MongoDB or are not familiar with it say that they want to try it out. So when you put all of this together, we started to collaborate with the team at Microsoft, and one of the most requested features for EFCore was a MongoDB EFCore provider. But for us as well, we got a lot of requests about having a provider that works with EFCore. So considering all the numbers and the requests that we had, the MongoDB EFCore provider comes into existence, and it really helps bridge this gap that we've just looked at. So in the past, C# developers could use MongoDB C# driver, but it didn't have first-party support for EFCore. So this meant a lack of official support or backing for EFCore if you were working with MongoDB. With the official MongoDB provider now generally available since May this year, you can confidently use C# and EFCore when you're building for production-grade workloads with MongoDB and EFCore. And like I said, we've been collaborating with the Microsoft team to bring this provider to life. And we're happy that we launched it, and we're going to evolve it with newer capabilities as we progress. Now, what are the benefits of the MongoDB EFCore provider? The first one is it allows you to leverage familiar APIs, query paradigms like LINQ, and design patterns. The second most important thing is there is no cloud vendor lock-in. Now, what this means is if you're using MongoDB Atlas, you can use the cloud provider of your choice, be it Azure, AWS, or GCP. And since the EFCore provider is built on top of the C# driver, which is an architectural choice that we made, it allows you to use capabilities that the C# driver exposes, which might not be available in EFCore, like Atlas Search, Atlas Vector Search for AI applications, which I'll touch on a little bit later, and index management and other admin type capabilities. Okay. All right, so now let's take a look at a quick demo about how we can set up EFCore to use with MongoDB Atlas and how we can perform basic CRUD operations, and then also show a glimpse of the index management capability that I just spoke about. So hope everyone's excited to look at this. Okay, I'm going to be looking at my other monitor, but what you see on the right-hand side here is MongoDB Compass. And it's essentially the GUI for working with MongoDB. It's a desktop app. And on the left is just a terminal. So we'll be working with a basic .NET console application in this example. So if you want to add the EFCore provider to a basic project, all you need to do is use the .NET add package command, and it will add the EFCore provider to your project along with any dependencies needed. Now we switch over to our basic console application, and this is what you would do in your program.cs file for connecting to any database. So you just create a client, you have the database itself, and then the important thing here for EFCore is the DB context. So you see here we have our own DB context called movies DB context, because in this example we're using sample data set which is available with Atlas. So we're using the sample movies collection. If you get started with Atlas on the free tier, you have access to all the sample data that you need. Now we'll go into the create function itself. So we were looking at the program.cs file. Now we're looking at the movies DB context file. So you'll see that it inherits from DB context, which is available with the EFCore package. And we have our own create function here, which takes in the database. Now, all you need to do to connect to Atlas is use the function called use MongoDB on your DB context options builder. And it takes in the database object with the database client and the database name. Once you do that, that's pretty much it for connecting to Atlas. The only other thing worth mentioning here is we also have the constructor, which is the default one, and we just inherit from the base. Now, the other thing that we'll be doing here is defining the DB set. So we have our own entity called movies, and we need to define that we're using a DB set called movies. And we look at the model class quickly, but you just have to define it here in your DB context. Let's look at the movies model class. So you'll see here we have different fields defined in our model class called ID, title, year, plot, rated, etc. We also have up top an attribute, which is a collections attribute. So the thing highlighted on top, what it does is it tells the EFCore provider that we are going to be mapping our movies, DB set of movies entities into a collection, similar to a table in a SQL database. And all the names here are not shown, but they are defined in a constants file here. So be it the collection name, the name of the database, the connection string, you can do so directly as well, but just for the sake of this demo, we've put it in a constants file. The other important thing to note here is if you see the movies model class, everything here is in Pascal case. And all the fields in the database initially when we were looking at Compass, you'll notice here are in camel case. So now what we can do is configure our conventions. So what that does, we're going to uncomment this part. What this does is it tells the EFCore provider that we're going to be using the camel case convention, which allows to map the fields in the database to the model class. So for each and every field, we don't need to do anything explicitly again and again. We just need to do this once, and this mapping will be taken care of by the EFCore provider. So we just make sure we have the conventions added, we define the convention, and that's pretty much it. So going back to our program.cs file, now we're going to do a basic read. So we have a lot of movies in our database, I think around 20,000. What we're going to do is we're going to write a query. We're using link here. So we're just doing db.movies.where, and we're going to find movies from the comedy genre. We will find movies that start with an A, and we order by descending with the year field. And once we have our results, we're going to take the first 5 results and then try to print them. And in the movies class itself, we had a toString function, I think, which allows you to just print the movies. There we go. Okay. Didn't want to go into too much detail there, but just in case anyone wonders how is this being logged. So now we're going to just run this project. Let's see if we get our movies back. Okay, perfect. So you can see here in the log, we got our 5 movies. Movie can have multiple genres. So we asked for comedy movies. So we have all the movies that have the genre as comedy. They start with an A. They are ordered in descending order by the year. And we also have some awards or nominations listed here. So this is helpful, but what if you want to see more logs? What if you want to see what's happening behind the scenes with the provider and how is it communicating with MongoDB? So if you want to do that, we go back to our DB context class. We can enable logging here, which is a pretty cool feature. And you can use any logger, but we're using just console.writeline. And you have to enable sensitive data logging just in case there's any PII, because this will be logged into the console. Once we do that, let's just save and then rerun our program. And what we'll see here is we do see the results for what we wanted, but we see much more details than we saw before. And I'll show one more interesting thing. So we see a lot of logs. We're just browsing through it, and you can see all the communication and all the logs being seen in the console. And you see this sample.mflix movies.aggregate, the highlighted line here. What is it doing? So this is actually the query that is being sent to the server. So based on the link query that we wrote in our program.cs file, you'll see we have a match stage, which matches the genre, the title, starting with an A. We have a sort with the year field. In descending order, we have a limit to take the first 5 results. And it's essentially converting it to an aggregate pipeline. So you have a clear view of the executed MQL with the server. So that's pretty neat. You can see what query is being sent to the server. Okay, so now we've seen how a basic query works. Let's take a look at how we can use the index management feature I just spoke about. So what we're doing here is we are leveraging the capabilities of the driver. I mentioned that the EFCore provider is built on top of the driver, so we are reusing the database or the Mongo client here that we defined initially, and we're just defining the convention here again, which I'll explain why. And we're creating a new index here on the title and genres field. So we are working with the title and genres field in our query. I want my query to be optimized, so I need to create an index for it. So this is just the driver code to create the index, and you'll see here create one async, and this takes in the movies index definition that you want to create. It's a compound index, and we're doing it in ascending order for the title and genres field. Coming back to the convention, like why are we defining the convention again when we defined it already in the DB context? So the important thing to note here is that this is for the driver. So the EFCore provider has its own data mapping for the model, and that's why we need to do it for the EFCore provider separately in the DB context. But if we're using any of the capabilities of the C# driver, then we need to do it for the driver as well. But you only need to do it once. So now we've done that. Just to make sure that we're going to call that task here. And then just to make sure that the indexes are actually created, we'll go in and check, does this index exist already or what indexes exist? So going back to Compass, I see that there's an ID index, which is created by default. And then there's a separate index I would have created before on the plot field, but not what we want for the title and genres. So let's run this program. We have not given any by looking at Compass again. Okay, we're going to do a refresh. Perfect. We see title underscore one underscore genres underscore one. So it did create an index for us. And you can also see the title and genres field here with an up arrow because we wanted it in ascending order. And like we intended, it is a compound index. So awesome. We have like optimized queries now with the field that we needed. Cool. Okay. So what we're going to look at next is a full CRUD and change tracking example. So one of the things I mentioned initially was MongoDB supports a flexible schema. So with the database, there may be fields that you have not defined before. So in this case, we are defining a new field on the fly in our model class called the book was better. And this field does not exist for any document in the database. So we're going to create a new movie entity. We're going to set this field, and then we're going to update few properties and then delete it. And we'll see the whole life cycle with breakpoints. So firstly, let's create a new movie called MongoDB The Movie for 2023. We have a plot, Lucky Little Database Revolutionizes Software Development. It is a documentary, and we're going to set the book was better field to true. But just to make sure that this actually works, we're going to go back to Compass, and we're going to search for this field, the book was better, and see if there's any document that has this field present. And once we do a find, you'll see that there is no document with this field. So we can confirm that this does not exist in the database. And like I said, you have to call save changes or save changes async. So we're going to create a new entity, add it to the DB set, save changes. We're adding breakpoints so we can pause and see every step along the way, how things are working. After we create the new movie entity, we're going to update the year to 2024 from 2023. We're also going to add a genre. So we know we only had documentary. We're going to add true story as well. And let's give our movie some awards because why not? It deserves some awards and nominations. We do the save changes async again, and then we finally remove the movie. So let's see how this lifecycle works. We have our code ready for change tracking for a basic CRUD operations. We run the program and then we'll wait for the breakpoint to hit. Okay, awesome. All right, so we're at the first breakpoint, as you can see. Let's step over it, step over the save changes. One thing to note here is if you don't call save changes or save changes async, the changes are local. This is standard EFCore behavior. So you see the changes reflected in your database only if you actually call save changes. Now, at this point, we've paused at, new movie.here is 2024. So a new movie should have been added with these fields. Let's go back to Compass and check that. We do a find again with this field we just added to our movie entity. Awesome. Okay. So we did find our movie that was added. So yay, congratulations. We can see that it's a documentary. We can see that the year is 2023. And we can also see that just go back a little bit. Yeah, we can see the year. We can see that there's no awards. The book was better field is true, which is what we were searching for. So now we're going to go to the updates and step over the updates and see if they actually get reflected in the database. So we update the year, add a genre, add awards and nominations, save changes, and then go back to Compass to see if it got updated. So we just do a find again, and yes. We'll expand on the genre. So now there's two genres instead of one. So you can have arrays, nested objects inside it, where genres is an array and awards is the nested object. So we have awards and nominations, yes, for our movie now. And the year is also 2024 instead of 2023. And lastly, let's remove the movie, sadly, and then save changes, and then go find it again in the database. And you can't find it anymore. So all of the operations succeeded. We're able to see how easy it is to set up the EFCore provider, how to perform change tracking and basic CRUD operations with it, and also how to use capabilities from the driver, like index management by creating a new index. And you can do much more with that. So the main thing to notice here is the only thing that's different if you're already familiar with EFCore is the use MongoDB function. So we use the already defined database client and the database name. And that's all that you need to remember if you've already been familiar with EFCore. I also want to showcase some of the key features that are available already since we've been GA in May this year, and then also what's coming up. So we are compatible with EFCore 8 and .NET 8. We already saw capabilities in action with CRUD operations, change tracking, embedded documents, link query support, etc. In terms of the upcoming features, what I'm excited about is transactions and optimistic concurrency, which is coming soon, this week actually, as we're speaking. So what this allows is it makes save changes and save changes async transactional by default. If you want to turn it off, you can intentionally. And we support two modes of optimistic concurrency. So you can define a concurrency token, like a last updated time field, and the onus is on the developer to update that. But you can also use a row version, which is an automatic update field where EFCore provider will take care of it on its own. There's other features also listed here, but we have our whole list available on GitHub. I can share a link later. And that's pretty much in terms of what's going to be available. What I do want to mention next is what else are we working on? So we spoke about the EFCore provider, we spoke about the driver, and how these tie together and how you can use MongoDB Atlas along with it. But 4 things I want to highlight that our team has been working on and is very excited to share updates on. Firstly, on the top left, you'll see the MongoDB.NET Analyzer. So for folks who are not familiar with this, it is an extension already available as a NuGet package. And it's a Roslyn analyzer, which allows you to see your queries at compile time in your IDE. So if you are working with builders or Link, you can use the analyzer to hover over your code with the mouse, and you'll see 3 dots, and then you can expand on that to see your queries even before they are sent to the server. So it's pretty cool in terms of seeing what queries would be executed as you're working and developing your application. Another important thing here is, as of yesterday, we shipped an update to the .NET Analyzer, and it supports EFCore as well. So if you're using the driver or EFCore, you can use the analyzer along with it. The next one below that, is better OData support. So OData is an extension that has been available in the .NET ecosystem for a while. So if you are working with OData, we do have an extension for MongoDB available. You can simply use the Mongo enable query tag on your code, on your controller's queries, and then it will just make your queries powered by OData. We've been working on improving the OData extension by adding support for better filters and compute operations. And in the next iteration or the next release of the extension, all of this will be available. The next one that I think a lot of folks will be intrigued about is our semantic kernel integration. So if you are interested in building GenAI applications, then you have the MongoDB memory connector, which allows you to store your vector embeddings alongside your data. So you can use Atlas to store all the data you already have with the vector embeddings. And the semantic kernel integration will allow you to query your data and create GenAI applications with that. So I'll just share a couple of links in the chat. And in case anyone's interested, I was able to get up and running with adding basic documents and create a chatbot in less than an hour. So it's very, very nice. The last thing I want to mention is the C# driver 3.0. So our C# driver has not seen a major upgrade in the last 8 years. So this is really the next gen version of our driver, which allows you to reduce a lot of tech debt, deprecate things, add new capabilities that we've been wanting to add for years. So we're really excited to introduce that. The estimated time for that is late September to early October. So we should be able to share more details as we make progress on that. Okay, I think that's all from me. I'm open to questions, but before we go to any questions, I also want to leave this up, which is codes or links available to view the documentation for EFCore. If you want to see the GitHub repository for the features that I just mentioned in terms of what's available, what are the limitations, what is not supported, but we're considering. And then if you want to engage with the community, we have our community forums. And lastly, our Jira board is public for any project. So for the EFCore provider specifically, if you've already used it and want to share any feedback, feel free to do that. Thank you, and back to you, Simon.